rectangle is decreasing at a rate of 2 centimeters per second. The length L of a rectangle is decreasing at a rate of 2 centimeters per second. Translation, please, into math notation. dl dt is decreasing -2. And we can put the units in there as well, centimeters per second. While the width W is increasing at a rate of 2 centimeters per second. Translation again into mathese. dw dt, which is not related to Arthur's sister. I did not know that. I did not know that.
Now you know. That's like what? That's something from some of the first episodes. Like when her mom gets mad at her, she says her whole name.
And like when she went to the library card, they didn't know spell her name. And there's a big hole.
Oh, wow. Did not know.
I don't know.
Yeah. Yeah, I always thought he was a mouse, but I found out he was an Arthur.
Neil Gaiman appeared on Arthur just a while back in September.
Why do I know Neil Gaiman?
He's an author. He's a famous fantasy writer.
Okay. Science fiction.
No.
Yeah. Fantasy. Fantasy. Okay, continuing on. When L is 12 centimeters and W is 5 centimeters, find the rates of change of the area. Okay, well, in part A, where we're doing area, we always have to start with the equation, and then we have to then take the derivative of that equation. So let's say, all right, if the area of the rectangle is L times W, now let's go ahead and take the derivative of both sides of that. On the left-hand side, it's going to be dA dt. On the right-hand side, gosh, it looks a lot like the problem that we had just a few seconds ago. We're going to have to do the product rule again. And that's going to be first times the derivative of the second plus the second times the derivative of the first. And then they actually want us to solve that. What is dA dt? Well, the value of dA dt when L is 12 and W is 5 is going to be 12 times 2 plus 5 times -2. So that's going to be 24 minus 10, which I think is 14. And the units are going to be centimeters squared per second. By the way, if you actually do the unit analysis, if you actually put units in here, 12 is in centimeters, 2 is in centimeters per second. So this product right here is actually in centimeters squared per second. 5 is in centimeter, -2 is in centimeters per second. When you multiply those together, you get centimeters squared per second. Units actually work out. All right. In part B, we're asked to find how the perimeter is changing. Well, again, let's start with writing out the perimeter equation. 2L plus 2W. If we take the derivative of both sides of that with respect to time, we're going to end up with 2dl dt plus 2dw dt. And then if we want to find it at the particular instant when L is 12 and W is 5, we're going to end up getting I guess there are no L's and W's in here. So it's always going to be the same rate of change in the perimeter regardless of the size of the of the 0.
Yes.
0 centimeters per second. But I guess that also could be 0 kilometers per hour. Little units joke there.
Lol.
Actually, crickets. Okay. And that should make sense. Where the width's getting bigger, or the length's getting smaller at the same size as the width is getting bigger, so they cancel each other out. Okay. And then the last one. The length of the diagonal of the rectangle. I don't think that's enough space to write that. Let's erase to create enough space to do the last problem. And I'm going to need a letter to signify the diagonal. J? J. J for diagonal. Okay, so what's the length of the diagonal? It's the square root of L squared plus W squared. Yeah? So what is the derivative of this with respect to time? Well, we're going to get dj dt. The derivative of this, well, we got an inside function, outside function. I think it's going to be 1/2 L squared plus W squared to the negative 1/2, and then chain rule. 2L dL dt plus 2W dW dt. I did that awfully fast. Did I lose you? Okay, so I'm using the same old rules. Just got just a slightly different feel to it. All right? So you want to? Can I get rid of this 2 and these 2 2's? Alright? Alright, so let's find out what is dj dt when L is 12 and W is 5. It's going to be 12 squared plus 5 squared to the negative 1/2. 12 times negative 2 and 5 times 2. Plugging and chugging there. 144 and 25. 169, great.
1/13.
Negative 24 plus 10, back to 14. This indeed is the reciprocal of the square root. Well, the square root of 169 is 13, so this is going to end up being 14 over 13. And it is going to be in centimeters per second. Yeah.
When you do 12 times negative 2 plus 10, would that give you a negative 14?
It would indeed.
Which would make the whole thing negative.
Good catch. Is that the right answer?
Yes.
Oh, good. All right. Any more questions? Yeah.
Cancel out the 2 and the 1/2.
The 2 and the 1 here. Well, I imagine myself factoring that 2 out of this expression, and there's a 2 out here, and then then they cancel. If there's a 2 in every single term across, I can cancel. All right. You know what the worst thing about that problem is?